Hello, everybody. Thanks for coming. My name is Dan Rein. I'm the chemist here at Jonas Chemicals. And this webinar, the topic is on, let me get the first slide up. The topic is on problem solving. This is a third webinar I've done this summer. So I plan to do one more for a total of 4. So the first one was on opening the pool, flocking, and also ways to reduce your chlorine usage by supplementing it with algicides and other ways. The second one was on the chemistry of chlorine. And so this one, I will go over some common problems that you see with pools and solutions. To give you a better idea of like the chemistry that's going on. Some of you might already, have experience, know what works and what not works, but maybe you can pick up a thing or two, details that you haven't before, or just good to go over once in a while and refresh. So if you have questions, you can use the chat. You can use the chat box. I can see any message you type, and or just contact me after call or email me anytime. I'm here to help you guys with whatever you need. And thank you for coming. Thank you for coming, attending this. It seems like it's catching on a little bit, so that's good. I like to see that. Thanks for coming to join me for this. So let's get started. So we'll just get into it with water testing is the first thing. Whenever you have a problem, you want to test the water, because how do you know what the problem is if you don't test the water? You might have an idea, but that's the best way to know for sure what's going on. And then you might catch things that you didn't know by testing the fill water too. Is always a good idea, especially if everything looks normal with the pool. So if your pH is off, for most tests, it could change. If your pH is off, it could change other results. You need to have the pH in the normal range around neutral, which is normal for pools, between like 7 and 8. If it's higher than 8 or less than 7, it might affect other factors that you're testing: hardness, alkalinity, things like that. You want to sample your pool water not from where any returns are moving water, away from any returns, and a few inches, 18 inches about below the surface, to get a good sample of water mixed in that's thoroughly mixed, not anything that's going right into the filter or coming out of the returns, as it could be a little bit different result. Also, when you add chemicals, you want to allow enough time for those chemicals to react and mix in with the water. Every chemical is different. Some will mix in almost immediately, and some could take hours or longer. So make sure that best thing to do is just test the water before you add any chemicals. And if you do, just wait a little while, as long as you can, for it to be mixed in well and any reactions to have taken place already. Also, something important, which I see a lot, is depending on your test method, each method has a different limits of testing. So this is the limits of testing for the Lamont Spin Lab. I just had someone ask me about cyanuric acid today, where their local codes require the cyanuric acid to be 0, and they keep testing the water and it's coming up as 5 ppms. Well, the important thing to note here is that the limits of testing starts at 5 ppm. So even if your cyanuric acid is 0, it might show up as 5 ppms. So anywhere close to that low end or close to the high end of that limit you can't really trust as being accurate. 0 ppms and 5 ppms in this case would essentially be zero. It's just like an instrument error where it uh it can't read that low or that high for that test factor. Each factor has a different range, and then different methods test strips might have different ranges for the chlorine than the spin lab, or every method is different. So that's an important thing to check if you're getting if you don't know what it is, just something to keep in mind all the time. So any most problems with pool water, you can separate into these three categories. So physical factors, chemical, and biological. And what that means is physical is probably the most important. It has to do with the circulation and filtration. So you can have a pool that you can maintain a pool with clear water pretty much with just filtration by not doing anything else, and you might be able to get clear water. That doesn't mean that it's sanitized. Things still could be growing in there, but filtration is really important. It filters out any particles, materials in water. It can even filter out bacteria, depending on the type of filter and the size of the bacteria particles or algae, whatever it might be. What common thing to check is if your filter is dirty. If it's a cartridge or DE, sometimes you can't get a chlorine reading. It's because the filter's dirty, it's contaminated, and that's what's using up all the chlorine. So you need to take it apart, check it, and deep clean it. Same thing with a sand filter. If the sand is very dirty and that dirt's not getting washed out through backwashing, that can eat up your chlorine and cause a problem where no matter how much chlorine you add, it's not gonna touch it. You have to change the sand or clean the filter real well to fix it. And then chemical factors have to do with water balance, which is pH, alkalinity, and hardness. Those three things are important for pool water to be kept within a certain range. Also, chemical factors include any metals in the water, your CYA level, and TDS, total dissolved solids. So the water balance is important just to keep everything balanced. Makes as long as your water is balanced, everything, chlorine and everything else will work much better than when it's out of balance. So biological factors contributing to water quality has to do with algae, bacteria that could cause problems. Sanitizer, usually which is chlorine, but could be an alternate sanitizer. Sanitizer just means some chemical that sanitizes the pool, and which means to kill bacteria and living things to a level that's acceptable as safe for swimming. And then the other biological factor is oxidation. So after things in the water get killed, they have to be oxidized as well, which means they get broken down into smaller compounds and eventually filtered out, or just broken down into and dissolved into the water. Chlorine is really good it's the only sanitizer that also oxidizes. So the chlorine can be used as a sanitizer. Most people use tabs. That's what that is. And for an oxidizer, you have chlorine shocks. You have different forms of shock that are chlorine compounds. And the purpose of shocking is oxidation. So some of the most common problems are just cloudy water or green water. So it could turn cloudy or green pretty quickly, or it can do it slowly over time. Some of the possible causes, I talked about number one, poor filtration. There could be something wrong with the pump. It's undersized, something blocking the circulation, so water's not flowing, or the filter could just be dirty or not maintained properly. Also, if there's not enough sanitizer, or it's being overwhelmed by stuff in the water, like a high bather load, it'll use up more chlorine, and it might not be enough. You might be not be adding enough sanitizer. Also possible is not enough oxidation, which is shocking or superchlorination, all mean the same thing. You might not be using enough shock treatment for the size pool. We recommend 2 to 4 pounds of a Cal Hypo shock per 10,000 gallons of pool water. So if you have a worse problem, go towards the higher end of those pounds. That should be done somewhat regularly anyway, or you can test your water and shock when there's combined chlorine. I go over some of that more in the webinar on chemistry of chlorine. So also debris from the environment, landscaping, storms, they can all cause stuff, organic stuff from the environment to go into the water. Fertilizer can cause problems with phosphates entering the water. And all those things, anything in the water will interact with the chlorine and cause it to get used up faster. So after adding chemicals could also cause the water to turn cloudy or possibly green. That does happen sometimes depending on what it is. pH up has a high pH, so it can cause a cloud to form, or a Cal Hypo shock can cause a cloud to form. Those will just go away on their own with circulation. They'll eventually dissolve back into the water. If your pool turns green after shocking, it's usually from copper or some type of copper present in the water being oxidized and turning green. So that's a little bit more complicated. Sometimes it'll go away on its own, or you might need to do a metal removal / sequestering treatment to really solve that. So that's the question when you have a green pool. The first question to ask, is it from algae or is it from copper? So if it's copper, it'll look like a clear green. You can see the bottom of the pool and it's uniform through the whole pool. It'll be a uniform color of green. The algae is more like blotchy, where algae forms in blotches. More cloudiness. You won't be able to see through the water. It'll look more cloudy, much more cloudy than it looks clear. And so that's a good way to tell just by looking at it. You can also test for metals, and if there's metals in the water, like copper, that's a good indication that the green color is from copper. Or if it turns green after shocking, like I said, that's a good indication it's from copper. So I'll talk about that a little bit later. But let's say that the cloudiness is from algae or stuff growing in the water, microorganisms. So the first thing you can try is to shock, pre-dissolve in a bucket and spread evenly around the pool, 2 to 4 pounds calcium hypochlorite shock. You can use Zap It. That's a calcium hypochlorite. Scorch is another one of our brands. So 2 to 4 pounds per 10,000 gallons. If you're not sure, go with the higher end. So it's better to use more and take care of the problem, so you don't have to come back and do it again. Better to use more the first time. So after you do that, run the filter 24 hours until it's clear, and backwash it as needed after a day or two, depending on how cloudy it is. If it's a very cloudy, very green, you might not want to do that, because you're passing all that dirt and debris through and organic stuff is passing through the filter and could cause problems with your filter. So the best thing to do in heavy cloudiness or heavily clouded pools is to use hydro flock. You can use alum too. It's another type of flock, but the hydro flock is a high quality one. Seems to work really well. You just add 1 quart per 20,000 gallons, and that'll coagulate and drop everything to the bottom, so you can vacuum it up and vacuum it to waste, so it doesn't go through your filter system at all. It just bypasses it and goes to waste. So yeah, a couple options depending on the severity of the pool. In certain situations, you might also want to use a clarifier. which will coagulate particles. But instead of dropping them to the bottom, the goal is that you run the filter system, and then it'll help the filtration pick up, take those things out of the water quicker than just the filtration alone. And poly 60 algicide is another similar chemical. It is algicide, so it has killing properties that helps kill algae, and it also has some properties similar to the clarifier, where it'll coagulate things together because it's a polymer. It's like, imagine like a sticky bubble, so it'll stick, create bubbles around these particles and make a little bit bigger of particles, so that the filter system can remove them easier. So any of those things will help clear up a pool faster, or make it even clearer. If you're not using any of these things, just adding a clarifier as a weekly dose will make your pool water look clearer, look more sparkly than it does even with just chlorine and filtration, normal filtration. These are what algae look like. Some of the green algae that you might find in a freshwater pool, just to give you an idea what they look like on a microscopic level. Actually, I think these are from a wastewater treatment pond, but I guess they could also be present in a pool in their non-saltwater algae. So the poly 60 algicide is a polymer. Like I said, the way that it kills things is by suffocating them. It forms a bubble around it and prevents respiration. Prevents the cell from metabolizing anything. Other ways that algicides work is sterilization, by preventing the cell from reproducing, growing, and starving it, which I guess is similar to suffocation. It'll also starve it from preventing metabolism. So just every different algicides might work a little bit differently, and sometimes if you hit it with two different kinds, if you have a bad problem, like with a metal-based one and with a polymer one, it'll work even better than just using one of those. But anything will help reduce your chlorine usage. Any kind of algicide, we recommend the poly 60, the algicide. It's a good polymer for killing algae. Also to be used as a weekly maintenance dose, because it'll help supplement your sanitizer, and you'll end up using less chlorine when that's present in the pool. Just a small amount is effective. Added once a week, and it helps kill things and helps flocculate things, similar to a clarifier does. So that's one choice for algicide. Another kind of algicide is a metal-based ones. We have a few different copper-based algicides. Algitech Plus, Algae Hunter are a little bit different formulations. This label's for the Algitech Plus, which is a sequestered copper complex. Any good copper algicide should be sequestered. It should not just be elemental copper, or just copper sulfate. It has to have some type of sequestering for it to be a good quality algicide. That's what helps it from coming out of solution and staining the pool. So if you're using a copper algicide, make sure it's a good one that has sequestering technology in the formulation. Otherwise you're creating a possible staining problem more than you would if it has sequestering built into it. So that we have a few different copper algicides. There's the Pink X, which is a low foam quad algicide. The quad algicides work really good if you have a problem, and most people that use them, I hear things like they're the old style algicides, but they still work really good. And the people complain if that they tend to foam, which is true. But the Pink X is a low foaming one, so you don't have that problem with it, and it still kills algae well. Especially if you have like a pink slime type of algae, but that's what it works best on. But you can it'll work against real, any kind, especially if you use it as a weekly type of a maintenance dose thing. It'll help kill anything that the chlorine might be having a hard time with. And then another metal based algicide is silver algicide. So instead of copper as the active ingredient, it's just silver. Yeah, metal algicides have been used for hundreds or even thousands of years. I read that, thought it was interesting. I read the Romans used silver urns to purify drinking water, and copper coins they would throw it into the water supply when they didn't have clean water to drink to prevent them from being poisoned when they were in strange cities. So it's not a new thing using metals to kill bacteria. I will say the silver algicide is a bit more expensive, and it's because it seems to be more powerful, a bit more powerful against certain types of algae, especially like black algae, is what people really like to use the silver algicide for. It's effective against black algae, whereas some of the other algicides don't seem to work as well. And this chart here, excuse me, just compares some of our algicides and what the difference in the formulation is. First two are pretty similar. The third one is not chelated because it's a powdered form. It's not a liquid. So the first two are pretty similar. The main thing is the copper percentage, and then they're both chelated. Then the form doesn't make a whole lot of difference, and the pH is pretty similar. This one's a little bit higher, but any of these three will work. These two are the better ones because they're sequestered, but either of these work fairly well. So another thing that's not an algicide it's called an algistat. So Borax contains borates, which I'm guessing you've all heard about by now. But if not, it does work by preventing algae from growing. So it doesn't kill active algae, but there's plenty other ways to do that, including chlorine, and preventing it from growing can be really effective. Prevention always seems to be better than trying to tackle a problem after it happens. So it works really well in especially in situations where it's hard to get a chlorine residual. If you have like a lot of organic landscaping or phosphates, things like that, people seem to have really good results adding borates to the water. And it works a little bit differently, the method, because you don't add it when you weekly, and you don't add it when you have a problem. You only need to pretty much add it once per season, and it doesn't break down in the water, except for if the water gets diluted, if you're splashing it out. Other than that, it doesn't go anywhere. So you only need to really check it and add more once per season. So it'll help you use less chlorine as well, because it slows down the microorganisms from growing. Helping out the chlorine that way, and especially if you're having trouble controlling the cloudiness or algae. Oh, and it'll make your water look nice. It actually lowers the water tension a little bit in the water to make it noticeably a little bit silkier, and adds a little sparkle to it. So has that aesthetic element to it too. So the recommended dose for borates in the water, and you can test it either with Spin Lab has a 4330, 4331 discs, both test for borates. We also have test strips that you can test borate levels. So you want to have between 30 and 50 ppms, which ends up being about 2 pounds per 1,000 gallons. And it'll raise the pH. So you need to add about 3/4 pound pH down per 1 pound of borax. So it is a lot to add. For a 10,000 gallon pool, you'll end up adding about 20 pounds, of borates, but it is only at the beginning of the season, and it can really help in certain situations. Yeah. Oh, and so our multi 3-inch tabs, our 3-inch multi tabs, whatever they're called, they do have a certain percent of borates formulated into them. So they'll add a little bit, not the full dose, but they'll add a low dose of borates every time you use them. Okay. I also wanted to talk about phosphates, since a lot of people have problems with them, and there's some good information, some not good information out there. But basically, if phosphates are not causing a problem, you don't need to worry about them. But if they are high and they seem to be causing a problem, or even if they're not causing the problems, if they're high, you might want to remove them anyway. But definitely, if they're high, if you're having problems with your water, it should be removed using a high quality phosphate remover. Ours is called PhosX. It's similar to some other ones on the market. Ours is the maximum concentration you can buy. I've seen others, some are around like closer to like 10%. Ours is 27% lanthanum chloride, and that interacts with it attaches to phosphates and forms a precipitate. And then as you circulate the pool, the filtration system will remove that compound. When you backwash the filter or clean it, it gets just washed out. So that's how it works to remove the phosphates from the water. So if you also want to test your fill water, a lot of municipal water systems add phosphonates to the water, and when they break down in the presence of chlorine, they form orthophosphate, which is what phosphates are in your pool. So test your fill water and see, you might be adding some every time you fill the pool, and it's good to know how much. If it's a little, it might not have too much effect, but if it's a high level, or you're getting phosphates from some other source like fertilizer, it's a good idea to just use the PhosX as a weekly maintenance dose. Use a small amount every week, and to stay on top of it and prevent any problems. The phosphates also combine with metals and form some like hard to get rid of stains too. So that's a secondary, just an alternate, problem that it could cause, and why you want to keep them low, trying and prevent any problems. So now I guess I'll talk about staining a little bit. That's another problem people seem to have, common problem, or is stains. Plaster and liner pools both get stains. So iron stain is one of the easiest things to remove. You can remove it just by precipitating it from the water between 8 or 9. If you raise the pH to 8 or 9, it'll just come out of solution. You can filter it out. Most pools are closer to pH 7 though. But if it's visible in the water, it usually can just be filtered out with whatever filter you have. The particles are large enough to, if you have iron stains, you can, or any metal stains, actually, you can use our stain removal procedure. which I'll go over. You can use that to remove the stain and remove the metal from the water, like iron or copper stains. Iron tends to be easier to remove than copper. So where iron stains are brown like rust, copper is usually like a blue-green color. Same with the stains, or the water can turn like a green. The oxidized copper can turn the water green. It can also, copper can combine with phosphate or CYA, cyanuric acid, and they form some they are rare, but I've seen like purple or brown compounds forming with copper. So like purple or brown stains that are formed from some kind of compound with copper in it, and those tend to be like pretty hard to remove stains. So there's maybe not like one answer for every kind of stain. Some might be come up real easily, and some might take a lot of work and to get rid of. What was I gonna say? Something else about stains. So so if you have a liner or plaster pool, so take a liner pool for example. If it's older and the gel coat gets damaged, it's not as smooth, so it makes it easier for algae or stains, anything really, to stick to the liner. You might so if stain removal does not work, or it's very difficult, or it keeps coming back, you might just be better off replacing the liner. If it's older, that probably means it's damaged anyway and should be replaced. Same thing with plaster pools. If you have plaster that's mottled or has imperfections, if it has corrosion, like etching and things like that, where the plaster is not totally smooth, then the rougher the surface is, the more algae and easier it is for things are going to stick to it and cause stains on it. So it's sort of like an uphill battle sometimes if you're trying to remove stains from a surface that's not in good shape. And so sometimes the only thing you can do to have like a permanent fix is to replace the liner or get the pool replastered. And then another kind of stain is like a brown stain that's not caused by iron. It's caused by tannins, which is leaves. If leaves sit in the bottom of the pool and break down over the winter or something like that, they'll cause stains. Our stain removal won't work for them because it's organic. It's a different type of stain. The way you remove them is just by chlorinating the water and by brushing. And over time and circulation, they should come up with enough. The longer they sit, the harder they are to brush off. But the chlorine helps, and the brushing is necessary to remove them most of the time. So the way to tell if it's a natural organic stain or if it's a metal stain is you take a vitamin C tablet, which is made of ascorbic acid. You can rub it on the stain, and if the stain seems to lighten or come up very easily, then it's probably a metal stain. So the ascorbic acid chelates the metals, but it won't work if it's a stain from a leaf. It won't really work. So that's a good way to tell what type of stain it is, if it's a metal stain, and if our stain removal system will be helpful or not. So basically what you do is you add ascorbex to the stain. It's a solid powder. It's powerful chelator and concentrated powder. So you add that right on the metal stain, let it sit. Or you want to add the Stain X on top of the ascorbex as close as you can. Stain X is a liquid, so you just add it on top. So it's in the local area. Then you wait about 15 or 20 minutes and start the pool's pump back up. So after you do that, add a double dose of the Majestic Blue Clarifier and run your filter for 48 to 72 hours, and then backwash. So what's happening, or the idea is that the Scorbex and Stain-X, the Scorbex removes the Stain-X chelates it, binds to it. The Majestic Blue helps it coagulate into a larger size particle, and the filter will remove it from the water over that time period. And then when you backwash, it just gets washed out permanently. So don't shock the pool until you backwash. That could upset the process. So you want to wait until you backwash to shock the pool. Your pool needs to be clear first to do the stain removal. If you have a cloudy pool and you're trying to remove stains, you need to address the cloudy water first, which is probably being caused by not enough oxidizer, sanitizer, and algae or something like that. Not the filter not being clean enough. So that should be addressed first. And after you have a chlorine residual and your pool water is clear, then you can attempt to remove any stains. And it should also go easier than trying to do two things at the same time. Because the stains won't hurt you, but if your water is cloudy or there's no chlorine residual, it's not safe to swim in. So that is why it has to be addressed first. Also, something you could do if you have a DE filter, DE already filters pretty small of a particle size, but if you have like a sand filter, you might want to add some type of filter aid or a little bit of DE to that sand filter before you do this process, because it'll help filter out even more of those particles, of those metal particles. Some of them can be tricky. So I would try everything you can to get as much as you can out of the water permanently is the best fix. Stain-X, so I just mentioned that as part of that process. It's HEDP, which is a chelant sequestering agent, and it's better for one-time treatments on stains. It breaks down in the presence of chlorine and forms phosphates in the water. So if you have so you want your chlorine level to be on the lower side. You don't want it to be 0, but it should be on the lower side when you're using the Stain-X, because it will interact with it, and the chlorine will inactivate the chelating properties of the Stain-X product. Now, Ketrol Plus is also a phosphate-based stain and scale remover, but this is very resistant to chlorine. It breaks down into phosphates, but it does so very slowly in the presence of chlorine. So this is a really good thing to use as a preventative. It'll help prevent metals from coming out of solution, iron and copper. It also helps prevent scaling from calcium on your heaters, on your salt cells, or on pool walls. So yeah, using it every week is a good idea if you have a heater or a salt cell, or if you have any type of staining or scaling issues. Again, salt pools, our Saltig line has a stain and scale in it, which I believe it should be the Ketrol Plus one. It might be a different name though. But as this, like I said, the calcium scaling can affect the cell on the salt chlorine generator. So it is using this will protect the salt cell and improve the function of that cell. Same thing, you want to use it as a maintenance dose. It does break down slowly, so just adding a small dose every week is the best way to keep an adequate level in the water.